Hi, my name is Shahroz Ahmed, and in this video we are practicing the question for the SAT Physics. So let's start off with our question. This is a subject test of physics, and in this video we will try to do like 5 practice questions. So in this question it says when a vector of magnitude 6 unit is added to a vector of magnitude 8 units, the magnitude of the resultant vector will be how much? So over here we have only been given the magnitude of the vectors, but we have not been given the direction, their direction. So let's suppose if both of them are in the same direction, this is 6 units, this is 8 units, so the resultant will become equal to 6 plus 8, that would be equal to 14. But if they are in the opposite direction, let's suppose this is 8 towards right and this is 6 towards left, so their magnitude will become, their resultant will become equal to 8 minus 6, that will be equal to the 2 units. And if they are in like some other orientation, let's suppose vector 6 is in this direction and vector 8 is in this direction, so we'll join them from head to tail like this. This is vector 6, this is vector 8, so this will be the resultant vector. For this value we do not know the we do not know the magnitude, so it could be either 14, it could be either 2 or any other value. So the correct option for this one will be option E. If they are added in the opposite direction, the answer will be 2. If they are added in the same direction, the answer will be 14. And if they are added in some random direction, so that we cannot find out their value, so it will be option E. So let's check the answer. Yeah, that's correct. Alright, so now let's move on to the next one. Alright, now let's see this next question. It says a 5 kilogram block is suspended by a cord from the ceiling as shown above. The force exerted on the block by the cord is most nearly. Look, the force that is being exerted by the block on the cord will be the weight of the block. That will be in the downward direction. But over here we have to find out this force that is being exerted by the cord on the block. So this will be the tension. In the downward direction we'll have the weight. So in this case, because it's suspended, so it's not moving, so the tension will be equal to the weight. So the tension will be equal to mg. M is the mass, and I take the value of g to be 10, so it'll become 50 Newton. So 50 Newton is the force that is being exerted by the cord on the block, so it will be option C. There you go, it's correct. Now let's move on to the next one. Okay, so in this question it says which of the graphs best represent the kinetic energy of an elementary particle as a function of its speed, where c is the speed of light. Alright, so the formula of the kinetic energy is K equals to half mv square, or in other words we can say that kinetic energy is directly proportional to the square of velocity. So as the velocity increases, the kinetic energy increases exponentially, and there is no constant that is being added into this formula. It means when the velocity is 0, the kinetic energy is 0. So we have to choose such a graph where the kinetic energy is 0 at velocity 0 and the kinetic energy increases with the square when the velocity increases. So it cannot be option A, because over here when the velocity is 0, the kinetic energy is not 0. It might be option B, because when the kinetic energy is 0, the velocity is 0, and when the velocity is increasing, the kinetic energy is increasing with the square. So this will be our option, but let's see the other options. In option C, you see at the beginning the kinetic energy is not 0. In D, as the velocity is increasing, the kinetic energy is not increasing by the square, it is just increasing linearly, so it's not the case. Over here the kinetic energy is 0 at the beginning, the kinetic energy is also increasing exponentially, but no particle can have the kinetic energy, no particle can have the speed greater than the speed of light. So over here this particle has exceeded the speed of light, so this will not be our option. So it will be option B, that will be the correct one. Let's check it. It's correct. Alright, so now let's move on to the next one. Alright, so here we have the next question. In this question it says a non-positive charge is located at point P, that is between the two unknown charges Q1 and Q2. So this P is positively charged. P is closer to Q2 than Q1. If the net force acting on the charge at P is 0, it may be correctly be concluded that for option A, both Q1 and Q2 are positive. Yes, they are positive because Q1 will be repelling the charge P and Q2 will also be repelling charge P. So yeah, it could be the option. Both Q1 and Q2 are negative. This can also be the option because both of them will be attracting this charge toward themselves. But we have to see more precise option. Q1 and Q2 have opposite charges. No, this cannot be the option because if this would be the option, then the force at point P would not be 0. There will be some force on this point. Let's see option D. Option D says Q1 and Q2 have the same sign, but the magnitude of Q1 is greater than the magnitude of Q2. Okay, so they have the same signs, so they are repelling the point charge P. Q1 is repelling more because it has more magnitude, and Q2 is repelling less because it has less magnitude. So yes, this will be our option. Let's see the last one. It says Q1 and Q2 have the same sign, but the magnitude of Q2 is greater than the magnitude of Q1. That's wrong, because if the magnitude of Q2 is greater than the magnitude of Q1, then Q2 would be pushing more as compared to Q1, and P should be here in that case. But that's not possible. That's not the case over here. So this will not be our option. Now, because we have to reach to the more precise option, so that will be D, not A and B. So we'll reject A and B, and our final answer will be D. So let's check it, and that's right. It's correct. So this is how we'll reach to the solution of such questions. Now let's move on to the next one. All right, so here is the next question. It says two small conducting spheres are identical except that sphere X has charge of -10 microcoulomb and sphere Y has charge of +6 microcoulomb. After the spheres are brought in contact and then separated, what is the charge on each sphere in microcoulomb? So we have two spheres. This is sphere X and this is sphere Y. The charge on sphere X is -10 micro. I'll just write it here. And the charge on sphere Y is 6 microcoulomb. They have come in contact with each other, X and Y, and after the contact they have been separated. So after this separation, we have to see what will happen. So when they came in contact with each other in this position, so the total charge will be added. So the total charge on these spheres will be -10 plus 6. That would be equal to -4 microcoulomb. So the total charge on these spheres would be equal to -4 microcoulomb. Now, because they have been separated now, so they will distribute that charge equally among themselves. So in that case, -2 microcoulomb will go with X and -2 microcoulomb will go with Y. So it should be -2, -2. So this should be our answer. So let's check it, and that's right. So this is how you will approach the questions in SAT physics. I hope you understood the concepts and liked my video. Thank you so much for watching.